Thank you.
Okay. Oh, thanks, Chloe. Okay, good morning, everyone. My name is Colin Gibson, and together with Rob Sanders, we formed Glas Data, and our focus has been on software that's sort of helps with better data management and data aggregation in the food supply chain and agriculture. Rob Cartwright brings a wealth of hardware experience and expertise with more than 20 years experience in building management services. So together we formed quite a good synergy of hardware and software and worked on developing a versatile IoT solution specially directed at agricultural sector and food supply chain as a whole. And this works from farm gate all the way through to retailers and ultimately the consumer. Oh, I have to click here. Okay. So what is the Internet of Things? Essentially, it's a network of connected objects able to connect and exchange data. It's commonly called IoT. In simple ways, you have things that sense and collect data and send it to the Internet. In 2018, worldwide, there were 7 billion devices connected. In 2019, this has grown to 27 billion, with 127 devices being connected literally every second. So you can see the popularity and everything that's growing. So essentially, there's a variety of services that people can use for data transmission and things. You've got the local area networks that most people know that are similar, sort of essentially Wi-Fi and things like that. And that's basically what you can compare that to LoRaWAN, except LoRaWAN is a sort of a low power wide area network. So it's got the different benefits of low power, low cost, easy sensor positioning, and very low data rate. So it's very suitable for just transmitting those bits of data that you need for measuring and monitoring. We opted for LoRaWAN primarily as an integration to begin with due to its versatility in application to farming and food supply chain because of the long range and low battery life. So you can put a sensor out in the field or wherever it may be required, far from the gateway, and it can still send data to the gateway. On the right-hand side, you'll see it's basically a coverage map which we use for planning the gateway installation, with the green areas being sort of the brighter green areas, the better coverage, and slowly diminishing coverage depending on the terrain. And that shows a scale of up to approximately 1.4 miles. But depending on the terrain, you can get coverage all the way up to 20 miles or so, or even longer. And the battery life for the devices can last up to 6 years, which is very impressive. So that you don't have to go out all the time changing devices and things like that. So essentially, what does it mean for you practically as a user is there are three main areas: increased automation, making it allows automating the mundane tasks, allows you to effectively deploy your employees and your time in doing things that really matter and are more productive in your workflow. What you actually require. Real-time monitoring and alerts. This is it brings cost savings. So you've got information coming to you all the time, which enables you to react very quickly when there's something that goes wrong. It would be an alert to your phone, and then you can actually mitigate that issue quite quickly before it becomes a serious problem. The greater productivity, so essentially easily monitor, record, control, and optimize processes to obtain the best efficiencies from your resources. And basically that boils down to savings and increased profits. So, and with that, I'll hand you over to Rob Cartwright, who will take you through some practical examples.
Thanks,
Rob?
Colin. Yeah, thanks, Colin. So my name is Rob Cartwright. I'm the Managing Director of Facil Limited. We are a commercial Internet of Things installer, and we specialise in this LoRaWAN technology. So it's LoRa sensor devices, the antenna installs, and the network services associated with it. So what I'm going to take you through some practical applications of how we use the LoRa sensors. So this one here, this is a slide on basically saving time. This is a local cheese producer, has underground wastewater storage tanks, which are remote from their factory. At least once a day in all weathers, they had to walk over to the tanks, lift the cover and manually dip the tanks to see the level, because this wastewater they needed to book transport for to take away. Without the need for wired power or any cellular network, we were able to install the LoRaWAN device. You can see it on the image there. You can also see on my camera, just a completely no cabling at all. And the battery in this device, it needs a little bit of extra power for this ultrasonic sensor, but we're still good for 2 years battery. So without any need to go back to that, it's really simple. This LoRaWAN device measures accurately to the millimeter the water level, and we transmit that to our cloud service every 30 minutes. So now the client can see the data, the level data, 24 hours a day from a phone or smartphone or PC. So a lot of time saving. I think as well, Colin's put some details there on actual cost savings as well, because it's obviously negated the need to go to the tank. This slide is on reducing waste. We had a client here with several water meters spread out across a 230 acre site, and it suffered several major water leaks. The cost to the client was many thousands of pounds. The water meters were manually checked just once a month. So imagine between those checks, all this water was leaking out, and it wasn't seen until they next went back and lifted the manhole cover. We've installed a small LoRa powered device, you can see in the image there, and it transmits the meter consumption every 30 minutes. The device is almost a mile away from our antenna, and it's down a pit and it's under steel manhole cover. So you get the idea of how far we can go with this signal. The aim here on this application is to create a virtual meter reading, so they don't need to go to the meter again. And we'll also do an automated alert should the meter leak again. So we're gonna have that ready in 1 or 2 weeks from now, and then we'll show it to the site manager. Okay. The image on the left there, that's a photo taken at Duchy College, where we've got this fully autonomous weather station installed. The power is derived from the solar radiation sensor. As well as taking the reading, the solar radiation reading, it supplies power to a onboard battery, and that supplies power to the rain gauge, the temperature, humidity, carbon dioxide, wind speed, and wind direction sensors. It's completely autonomous. As this device uses the LoRaWAN based radio technology, we can sight this several miles away from the antenna. So it's very flexible. This slide here is about basically mitigating issues before they arise. With these images, we have shown you some very practical applications of the LoRaWAN technology. We've installed a temperature sensor on several bulk milk tanks across Cornwall and gather real-time data remote from the site. We are also collecting temperature and status data from the refrigerant cooling systems. With this data, we're able to provide real-time alerts to the clients, and that's both the producers and the farmers. So you can see it's useful for producers as well to see a range of bulk tanks that they're supplying into them. This one is a water boosting application. Boreholes are often distant from farm buildings, and problems are only brought to attention when the storage tank is empty. We've installed a static pressure sensor on the borehole pump output to ensure the correct water pressure is provided, and we've also put water level monitoring, like the same sensors as this again, in the water tanks. So we're getting it both ends. We're getting it from the borehole. We can check the pressure, but we also check the water level as well. This one here, the image on the left is it's a shipping container. It's a shipping container freezer facility. The insulated steel container is chilled to -20 degrees C for long-term storage of our client's raw ingredients. Before now, the client was unable to deploy a temperature and humidity sensor due to the connectivity issues associated with this thick steel box, basically. The LoRa radio signal easily penetrates through the steel box, and we provide data to their dashboard every 15 minutes. In this live example, on a Sunday morning, the client was alerted to an irregular rise in temperature. So the facility manager went out on the Sunday morning and found out the cooling fan had failed. So they obviously got it repaired and saved all the stock. This one is smart room and bolus. So if I can show you this, that there in my hand is, you can see my video, is the actual bolus. It's completely sealed with the LoRa radio technology inside it and a battery, and it's got a 6-year battery life. And effectively what we do is this smart room and bolus deployed across a dairy herd provides real-time temperature and activity data from which we can accurately predict heat cycles. And if we don't miss a heat cycle, then we're increasing the total yield over the year. So the actual implementation of the technology, I've showed you a few examples there. The way we actually do this is with this single LoRaWAN antenna, but there are many applications. And as a hardware specialist, I'm always looking for new applications. We're currently looking at installing the small gateway into tractors and also sensors onto like mobile production units. Those used by sort of like casual labour in picking. So you can see there's lots of application. We just, as a hardware specialist, we can apply a sensor to that. What we do, the actual antenna itself, the central hub, which is that you can see in the middle of the slide, and also top left there, the central hub for the sensor data flow to the internet and to the dashboard is the LoRaWAN gateway. This device is typically located at a building that provides both power and internet. We look for tall buildings to mount the external antenna, and that gives us then many miles of range. For indoor applications, we use a small router. It looks like a broadband router, and it's simple. It's a simple 5-minute installation. And for projects where there's no power and no internet connection available, what we do is we've got a completely autonomous solar-powered unit with its own onboard 4G backhaul, we call it, and that's the image on the right. Eggbase. This is an excellent example of an Internet of Things solution. Don't scoff. So Glas Data are working with Eggbase and their egg producer clients, and the Internet of Things gateway, which is the picture in the middle there, and also on the left, was installed in less than 5 minutes. It was simply screwed to the wall, plugged into the socket outlet, and then plugged into the broadband router next to it. Then what we did is we screwed small battery-powered devices into the hen houses, and they were temperature, it was humidity, light, sound, carbon dioxide, and we're also working with the clients on a hardware solution to monitor feed consumption. And the way we're going to do that is we're going to measure the weight of the silos outside. So you can see there's a slide there with many different sensors. Other solution providers, the standard is for a user to receive a dedicated piece of sensor hardware that is linked to an independent dashboard. Eventually, the user ends up with multiple dashboards, multiple logins, and lots of siloed data. Our approach is to address the client's need directly. We've already configured over 60 devices that are all connected to one central platform, which is the Glas Core dashboard. So I'm going to hand you over now to Rob Sanders, and he'll talk you through the cloud application.
Thanks, Rob. I'm not sure I can top the excellent pun you did earlier, so I'm just going to copy it. So yeah, hi everybody. My name's Rob Sanders. I'm the other co-founder of Glas Data, and I'm slightly more on the technical side of things. So I'm just going to give you a quick overview of the dashboard and the software side of things. So our whole purpose, as Rob said, is basically to aggregate data from all these different places into one place, basically to make life easier for the user. So if it's coming from an IoT sensor, if it's coming from historical spreadsheet data, if it's geospatial data that you've imported from somewhere, it can all come into one place and it all links together, and you can see a complete, we call it a holistic picture of how your business is performing. And most importantly, you can either react to things going badly, or you can actually detect the trends which kind of tell you how to improve things. That's the whole purpose behind Glas Data. This slide here is basically it's a screenshot of your dashboard. So this is what the system actually looks like when you log in. And this is just a way of tracking your KPIs, the things which are most important to any individual business. This is completely adaptable on a business by business level. So you decide what you want to track and what you want alerts on, and how you want to see it. We have three kind of main pillars to our system. So the first thing is what you call relational or tabular data. So this is basically an Excel spreadsheet. So you could actually use this system for a drop-in replacement for Excel, and you have full capability for writing functions and organizing data as you would in a spreadsheet. The second really important kind of pillar is real-time data, which we've been talking about. The whole purpose of this webinar is to explain how IoT devices can help bring data really quickly into the system. And the third is geospatial data. So historically, we've been looking about how things change over time, but we also care about how things change over space. So for example, you can link sensor data to specific locations on a map and see how things differ and why they're differing. This here is actually a screenshot of the map. So you can see that we've got some fields marked out here. Now these are coming from the RPA, which is the Rural Payment Agency. And then we've also got some points, like pins dropped on the map, which represent locations where sensors are. And you can link, the physical data that's either coming from a sensor or has come from a spreadsheet, you can actually link it to a field or a point, and you can jump straight into that specific bit of data, or you can create graphs which will show you the differences between locations. So just in summary, before we wrap up, and I think go into a Q&A, basically this technology is designed to make your life easier and more efficient, and hopefully both mitigate unforeseen costs and also improve your productivity and therefore your revenue. And of course, we have it on desktop and also mobile, so you can be looking at this stuff on the go, and you can start reacting to things in real time. Thank you very much for your time, everybody. I'm not sure if Chloe's going to come back in and read out some questions, but if anyone has any questions, please put it in the chat, and we'll do our best to answer them.
Hi, I'm back, and I'm going to get Colin back as well. Okay.
There was one question I saw earlier from Helen, which was, what is the coverage and how do we know if we have coverage at the business?
Yeah, go for it.
I don't know if Rob Cartwright, you want to do that one?
Sorry, Rob, I was just answering a different question. Say that one again.
So Helen earlier asked, what is the coverage of LoRaWAN and how do we know if we have coverage at the business?
Yeah, well, the actual coverage of LoRa, of the actual LoRa radio signal is really long distance. So if we say it conservatively, in a built-up environment, we're looking maybe 1 or 2 miles coverage. If in an open area, which is things like farmland and things, you're then looking at tens of miles. The actual longest radio signal for LoRaWAN is over 700 miles, but that's a rather sort of special with nothing in the way. But realistically, on farms, we don't have any connectivity issues with just one antenna in a central location covering the entire farm. How you would know if you've got coverage, all you do is send us your details, and on one of the slides, if I take it everyone can still see the slides, the coverage map on the right-hand side there, that's a software tool that we use. We've got all of the radio propagation data that we use, and that is a reasonably accurate map of the coverage. So what we'd actually do is plot your area and see if there's any, see how far we can get any blind spots at all. Okay.
Brilliant. There was another one for you as well, Rob Cartwright.
Go on. Is it?
It was from Fiona.
Yeah, well, I've just answered it on the chat there, and Fiona's asking, how is the water meter reading the sensor? Is it a camera looking at the counter, or is it measuring flow? Well, what we do with the water meters, and I've been connecting to water meters for over 20 years, so most water meters have a magnet in to pick up to activate a read switch. Some come with a cable, some don't, but in fact we just buy the cable for the meter then, and once the cable's on, we connect that to our LoRa device and convert the pulse output. We basically count pulses, send that to the dashboard, and at the dashboard we convert it into litres or into meter cubed. What we also sell now are meters with embedded LoRa, so the actual meter itself has got the LoRa device inside it. Okay.
Someone was asking if we could have. Are you able to share your screen and have?
Oh yeah. I think if Chloe, if you make me a presenter again, I can share my screen and see. I can show you the dashboard.
Great. Yeah, I will make you presenter. We're only allowed a certain amount of presenters on this
there we go.
software, is why we keep switching around.
Let me just log in quickly. Okay, share the screen. That one. There we go. Is that showing, Chloe?
Yeah.
Oh, brilliant. There we go. So very quickly, this is basically the dashboard that we were talking about earlier. So this here is a very simple graph of temperature over the last 24 hours. And you can actually zoom into a section that you care about the most. And you can zoom out to see how data is changing. We have a few more graphs here, slightly more complex as well. We've got a weather station graph, which is showing you quite a few data points over time. So this is an example of how you can track. So this one's tracking temperature, pressure, and humidity all together. And clearly there's some correlations here that you might be able to see, or not, either way. So this is basically where you track and plot all the things that you specifically care about. If we jump into the actual data section very quickly, each one of these cards here represents like a strand of information that we are tracking. So for example, if we go into office temperature, this is actually a sensor which has been in our office, which I now think, given coronavirus, is in Colin's fridge. But if we click on that one, however many sensors you would have reporting temperature, they would all appear here as separate cards. And if we click on one of those, you can then see what's essentially an Excel spreadsheet with all the information here. And you can see we've got about just over 1,000 data points now. And that's basically just as data is coming in from the sensor, it just appears in this table and it grows over time. If we go back to what we call the tool shed, So this is where we have kind of like our own little mini app store where you can choose which integrations and third-party things that you'd like to access your account. And we have one here just called IoT Device Connect. If we open that one up, once it's loaded, it will give you a summary of all the devices which are connected to your account, and then you can rename them and organize them as you see fit. If I just reload that, sometimes it's a little bit slow. There we go. So you can see, for example, the Glas Data Office sensor here, which is pinging all this information. So light, motion, temperature, rotation, battery life, and humidity is all coming off one sensor and coming into the dashboard. And we can choose which bits we want to visualize. And even we could start visualizing that with spreadsheet data as well. I will leave it there. And I think there's been a few other questions on the chat.
Yeah, should I, Rob Cartwright, are you able to answer this one about the cost of the system?
Yeah, I'm actually just typing an answer to Lupo now, so I'll read it out as I'm typing. I mean, variable as always is the cost. A small gateway, a small internal gateway with a few sensors, less than £500. Because I mean, it's really and what you've got to consider is the fact that it's so simple to install. It's like a broadband router in effect. You just plug that in. And your sensors, you've no cabling at all, no thought about SIM cards. You just deploy the sensor. So yeah, less than £500. And I've put there to Lupo, if you already have LoRaWAN network coverage, which is what we're obviously expanding. We're expanding the network coverage. You only need the sensors. You don't need the gateway because you've actually got coverage already. You've got a network provider there. So maybe £100 for a sensor. External gateways, different because an external gateway, you've got to consider the installation cost, and you can see on some of the slides. Can I, Rob, can I pinch the screen back?
Yeah, of course.
How do I, is that the...
I'll put you back on the slides.
Yeah, cool, okay. So if I just go to that slide, you can see on the slide on the left, the scissor lift. So this is Duchy College again. There's a cost associated with that installation there, but then this is for a massive area with lots of sensors. So you're then sort of talking of £10,000-20,000 worth of a system. But the savings, if you consider the savings for the water meter, which is that one there, so that's an external gateway with there are a total of 11 meters. 1 meter wasted, lost £10,000 worth of water, and 4 meters had leaked. So in just saving those leaks pays for all of the investment in the LoRaWAN. And then you've got the capacity to put even more sensors. And on that particular site, we've got not just water, but electric meters, people counters, all sorts. I mean, there's so many sensors. So I'll just I'll press return and send that one to Lupo. But it's a variable one. It's for simple ones, for indoor applications, office things like that, it's less than £500.
Sorry, Rob. They all seem to be hardware questions. So another one is: can the sensors be installed underwater? Yeah. Okay,
this is Cameron. This no, it's the answer. So the way we do that is the sensor device. Yes, we put the sensor underwater, but the actual transmitter, the LoRa transmitter, the radio propagation is no good underwater. So what we do is actually float the antenna. We've got several applications there where sensors can be underground. One thing I was looking at with locally here in North Cornwall is with a Beach Guardian group, was to put temperature sensors, bond temperature sensors into rock pools. But we're obviously looking at making sure it's secure, so we're not adding to any pollution and litter, and bond that in. And what happens is it monitors the temperature while the water's over, and then when the water is off, it transmits, because we'll just transmit just several times a day. and that's one way of doing it. But certainly for a sensor itself, we tend to put the sensors in the water and antennas out. Okay.
And how many sensors can run through a single gateway?
So sensors through a gateway, you're looking, well, you can do like 10,000 sensors through a gateway. The most we've got at the minute is 3,000, and that's absolutely fine. They're working fine. But I'd probably say maybe 5,000 devices. Okay. I can see a question there from Andy Davis. Hi, Andy. Will the sensors integrate into other building protocols, Bacnet and KNX? Good question, Andy. Yes, they will. So the way we do that, Andy, is we convert it to MQTT. So getting technical now for you, you'll know it, you'll want a technical answer, is we take the LoRa radio device into the gateway, and we either push it to the cloud and convert it to MQTT, and then you can have an abstract MQTT driver in like a Tritium J device, and then we subscribe to an MQTT topic in your building controllers, and from there then you can convert it to what you want, Bacnet, Modbus, KNX, or what we do is on the gateway hardware itself, we LoRa into the gateway, convert it to MQTT there, publish that MQTT topic to a broker, and then you subscribe to MQTT broker from your BMS device. So yes, it can be done. And I've got two examples of that, Andy, if you want to see it. Okay.
Okay. I think we're hoping to run a construction version of this where we might be able to get more into those nitty-gritty language.
I mean, this works for even in this, for this audience, I say, especially with like producers with factories. Their factories are running these types of protocols, these building services protocols, especially Modbus. So it makes it really valuable for them to be able to put easy to deploy sensors. If you think of a cheese producer, massive maturation stores, what we can do is we can put hundreds of sensors, temperature and humidity sensors through those maturation stores, bring them to our gateway, and then actually integrate them seamlessly into their existing SCADA packages. So that's the power of it.